Hello and welcome back to our How to Spatial Work video guide series, created by HIverlab. SpatialWork is our AI-powered low-code digital twin software. Digital twins made easy for everybody and for a more sustainable future. In today's intermediate tutorial, we'll introduce one of our latest features called Spatial Heat Map. Spatial Heat Map is one of the most significant features of SpatialWork. It's a feature that allows users to generate data patterns in space. Previously, we introduced a series of data visualization templates, including the value chart, the gate chart, bar chart, pie chart, and table chart. However, those data were considered projected or tagged in the space, but it wasn't really natively computed and generated in the environment. So, with the Spatial Heat Map, it's the very first feature that utilizes the native capabilities of SpatialWork to populate data. Let me give you an idea of how it works. Imagine you have a factory that has a lot of sensors, for example, temperature sensors or air quality sensors. You might have data samples for every single point, but you want to look at an area that isn't covered by a sensor. How can you do it? Using the Spatial Heat Map features, this is going to allow you to create this. In a nutshell, you can place the sensor in the space and add the data. Then the Spatial Heat Map will automatically create gradients based on linear transitions, generating the estimated values and patterns in zones that were not covered by data points. Allow me to show you with one quick example. Let's start with some static data. In this environment, I just put in a list of objects. These objects are actually just representatives of sensors. I put all of them in the sensor group. If you click on all of them, you can see these are the different objects in the group. The sensor names have been renamed, so we are using a data point that looks like this. It's IoT data. Be mindful that whenever you look at the Spatial Heat Map, you must make sure that you know whether you are dealing with static objects or dynamic objects. Static objects are relatively simpler. You need to have a 3D object already built and added to the SpatialWork environment. In addition, you must make sure that the objects have been grouped and put under a group. The object names should be properly named because later on, we will be matching the objects with the sensor data. So now, if you look at the data source, you have device names like Sensor 1, Sensor 2. This is a list of 12 sensors. All these sensors will actually be able to be used in this environment with all the sensor names. Next, to start with the Spatial Heat Map for static objects, first, choose a group. Then, go to the Spatial Heat Map icon and click on it. The moment you click on it, it will show a configuration. Make sure that you clicked on a group. If you didn't click on a group and clicked on something else, for example, a single object, then the moment you click on Spatial Heat Map, you won't see anything. Because for static objects, it will only recognize a group. The reason is, if you only have one object, there is not much value in using the heat map to create variations between these objects and their surroundings. So the estimated heat map only has a value when you have multiple objects and multiple sensors that have been deployed in the space and have been spread out. There will be some zones that don't have any sensor coverage. So that's where you can try to use the Spatial Heat Map to populate the data. Next, let's go back to the selection of the group object. Select Spatial Heat Map and give it a name. We will name ours Sensor Heat Map. For the query section, we'll just leave it out because for now, we'll just go with a very simple sensor reading. In this case, let's choose this data, static 12 sensor data. Then now we can choose some values. These values are based on the readings we get from this D-soft sensor. So the sensor probably has temperature, humidity, and other data. Let's use the temperature as an example. Since this is just a test, let's go with a value of 20 to 60. Next, let's process the query. Once you start processing the query, you'll see additional options for parameters. By default, you need to choose a parameter because the parameter is the one that you extract from the D-soft sensor, from the parameters in the sensor object. Once you choose the parameter, for example, temperature, based on this value, it will start to generate the spatial heat map that is relevant to this value. We also enable you to show an additional parameter, which is the vertical one. Why do you have two? Because in a spatial heat map, since it's a 3D space, sometimes it might be valuable for you to have two parameters that are both visualized, and you can observe the relationship between the two of them. For this example, I'll just choose humidity for now. Next, let's save it. Now the heat map is saved. We can view it by going to the viewer mode. When going to the spatial heat map, now I can choose the sensor heat map. You can see the sensor heat map has generated the heat map based on the sensor position. Each of them represents one sensor. In this environment, for example, I can see that maybe the sensor installation position is wrong. To rectify this, I'll make some adjustments. First, go back to planner mode, then go to the right-hand side panel where you see the sensor group. Then, click on the sensor you want to move. I'll move it here first. I will also move sensor 2. I'll just move it closer. There are no limits as to the amount of sensors you want to move. You can move multiple of them. Let's move them very close to each other so we can see the result. Next, let's go back to the sensor group. Go to the spatial heat map. Based on the same settings, we'll just do it one more time and save it. I'll choose temperature and humidity and save it. Now you can see the sensor data has been regenerated and populated as well. Next, let's go to the viewer. For the viewer, the spatial heat map setting includes a few parts. One of these include the ability to choose how you want to set up the value to be spread out using the ratios. The ratio for now is 1. If you choose 5, you can see how the data reacts. The values start to merge with each other, then blend in, so you can even choose a higher value. When I choose 6, you can see the data fully merges with the other. For a static sensor, what you can do is also view the variations across the timeline. To do this, simply use the historical viewer. Next, let's choose the sensor values data source. For the data, we'll choose something simple. Don't worry, allow for the automation to do all the adjustments for you. Now we can make some adjustments to the time. In the same panel, input the information you want to view, including the start time, date, end time, and if you wish to enable or disable the spaghetti option. Then your timeline will appear after you click on the process button. Now, let's drag the timeline. You can see as we move the time, the heat map regenerates on the timeline. You can also use the timeline to do a live play by pressing the play button. The data updates when the timeline is refreshed. This group is sample data, but there are some similarities. After clicking on the timeline, as we wait for the data to refresh, for a brief moment there are no values, but you will notice some variations. Maybe a few seconds or a brief moment later, you can see that it is working when placing a sensor on the timeline with the data. If you want to see slightly more accurate variations, you can change some of these values. To do this, first make sure you are in planner mode. Next, select Spatial Heat Map from the panel on the left-hand side. Then select your sensor group located on the right-hand side panel. Now click on the Spatial Heat Map icon one more time to open up the data panel. We encourage you to experiment with the values until you get something you are comfortable with. The changes should be live. Let's see what happens when we change the values from minimum 30 to maximum 50. As you can see, some variations are immediately updated in the SpatialWork project scene. So this is actually the static sensor, the static diffusion heat map. The heat map generation is in real time. The loading frame rate might be a bit lower during some intense computing, but eventually it won't affect the accuracy of computing. Okay, now let's move on to the next test. So just now we introduced a static heat map, but what if you have something that's not static? We call it dynamic. I'll give you an example to explain what dynamic means. This is a static heat map because you have all the sensors that don't move at all. However, this is another data format. This is a dynamic object. Usually it is an object like a robot. Imagine you have an AMR or an AGV moving in a warehouse and you check the light position of it. Of course, we also populate or capture the status like battery or signal quality. This is quite a standard data format. How do we generate a heat map for this? First, let's go to the scene project. For dynamic objects, the settings and the options are slightly different. First, we look at the dynamic object heat map. The initial task that we may want to do is to analyze the movement behaviors of the robot in this case. This is actually a default feature. Next, let's choose the object group, which is this dynamic object group. To add a dynamic object, as previously mentioned, in a dynamic object, choose your historical dynamic data source. Then use the robot object to represent it. So right now, it's representing the latest robot position, and that is currently the object that has been saved. Now, if you want to create a dynamic object heat map, a spatial heat map, remember that it can only support historical dynamic objects, because a spatial heat map needs to populate all the positions in the time record. So if there's only one instance of a position, the heat map cannot be processed. That is why this dynamic object with historical data can be used to generate a spatial heat map. But if it's a live dynamic object, it doesn't work. Right now, we'll select it and go with AMR. For dynamic objects, there is no need to search for any data source. This is because dynamic objects are based on the data source of the dynamic object. It's not based on the 3D model, so the data source is already locked. The only thing to do is to click on the Process Query button. Choose a minimum and max value. But for now, we will skip this step and simply click Process Query, because these values can be changed later. Once you process the query, you will realize that you are also populating the option to select parameters. But we'll also skip this for now. Next, let's save this heat map and go to the viewer. Once there, go to the Spatial Heat Map again. Then go to the AMR history. Now, you can already see the heat map. This heat map is actually representing the robot's position. Let's change to a higher value, for example 5. Now notice the changes in the SpatialWork project scene. You can now see the robot's movement coverage map within this room's spatial heat map. If you want to have better visibility of the dynamic object's movement data in the spatial heat map, all you need to do is go back to planner mode and change the values under the Process Query button in the min and max values box. Here is how the heat map changes when we put a minimum of 20 and a maximum of 50. Now let's lower the value from 50 to 30. Let's also change the minimum value from 20 to 22 and see what happens. Alright, now you can see the movement data more clearly. The green color represents the robot's faster movements relative to the environment. Red represents the robot's slower movements and the amount of time it tends to stay longer in the zone. This is what the spatial heat map looks like. It shows the data in a clear and simple manner, making it easy to visualize. We are able to also click on the data. But of course, this data represents the latest batch. So this is how a default spatial heat map showcasing the movement data looks like. But what if I wanted to use something else to showcase other data? First, let's go back to the dynamic object within the planner mode. Then, select the heat map setting and go to Parameter. This is where we can choose to look at various other information. For example, we can choose the value of the signal. Let's choose wireless quality. Then let's save the heat map again. After saving the heat map, you can see the changes live within the environment, and it looks quite interesting. For example, you can see there is now a colored bar. This bar is based on the value of the height. So the higher the bar is, the value is relatively higher. That's where this value is. Of course, when in viewer mode, you can make some adjustments to this view. For example, if the height is too high, we can halve its value. Now we should see a little more clearly. The height of the bar also represents the signal quality, so now we can see this area has a better signal quality compared to other areas. When the bar is higher, it is able to create a good visual perspective. Imagine that you have a robot moving in the warehouse. In different areas, the robot starts to capture data around it. The data can be of different types. For example, it can be temperature or a signal of some kind. When you let the robot run around the whole warehouse, you can then use the spatial heat map to populate the data visually. This can include, for example, a temperature map or air quality map, so on and so forth. This is actually the benefit. Firstly, you can have dynamic objects able to project your data in space. Then, when using SpatialWork, you can actually create individual populating points for your data elements to be generated. Then, since we have the three-dimensional data chart, it is able to generate something like a terrain. So it is able to project a sense of the value around the whole space. It is very effective, especially when I have some objects moving. Now, imagine you want to reduce the number of sensors but still gather data. You could use a moving object that carries the sensors around, which would provide the same insights for your facility management, but at a much lower installation cost. Although we showed you a default dynamic object heat map, you can of course make it a bit more in-depth to give you even more valuable information. For example, you can add in the values including both the battery and wireless quality. Then you can process it again. When adding more data within your spatial heat map, you may notice that it will render the visual data differently. For example, after we added the battery value, that data appears red because we're using a low threshold value. We encourage you to experiment and adjust the value yourself. Then you can see the changes live. This should give you a good overview of how to use our latest and exciting spatial heat map feature for both static objects and dynamic objects within SpatialWork. Remember to join our LinkedIn group and YouTube channel so you are notified as soon as new features and updates are announced. Thank you for watching. See you in another video shortly.